Hi, I'm Andy Herbic, a senior in mechanical engineering and the lead for the Argonia Cup competition for Final Frontier Aerospace Systems and Technology, K-State's Rocketry Club. This will be our third year competing at the Argonia Cup competition. We're excited to display what we've been working on this year. We will be launching a 3.5-inch diameter, 7.5 foot tall rocket that will deploy a servo-actuated parachute recovery system at apogee, performing a standard dual deploy. Our rocket is almost entirely scratch-built with the entire exterior made of fiberglass. Our body tubes and coupler were wrapped around PVC and 3D printed mandrels, and our nose cone was hand wrapped with fiberglass strips. And finally, our fins were made with a vacuum infusion system developed by one of our team members.
Hi, I'm Parker Lange, a senior in computer engineering. This year we'll be flying on an Aerotech L 1090W motor using reloadable 54mm casing. Open rocket simulations estimate that this will take us to an apogee of 8,740 feet in 19 seconds, where we will deploy our nose cone integrated recovery system as well as a 40-inch recon recovery drogue parachute. Our booster will descend using the drogue to under 1,000 feet, where we will deploy our 60-inch recon recovery main parachute, which will slow our vertical descent velocity to around 22 feet per second. Our main flight computer is a telemetron, which provides dual deployment and GPS telemetry. Our backup is an Easy Mini, providing secondary ejection charges if needed.
Hi, I'm Caley, Eslick, a junior in mechanical engineering. Our design this year features a servo-actuated recovery system that is integrated into the nose cone. Here's our 3D SolidWorks model. Here's the antenna that's attached to the golf ball mount, which is how we're going to carry our payload this year. And the antenna is connected to our custom electronics board. And then this right here is the servo that has the winch that will control the parachute.
Hi, I'm Cullin, Dawdy, a freshman in mechanical engineering. This fall we purchased a parachute online through the recovery system. It was a parafoil wing and it did not meet our standards because it did not have a consistent glide slope and also had line tangling issues. So what I decided to do was build my own parachute over winter break, and I made a ram air parachute with the help of Dave Puster using ripstock nylon and 400-pound Spectrum line.
Hello, I am Brian Parks, a junior in computer science at Kansas State. For the recovery system this year, we decided to develop a reactive control system. With this system, we generate a tolerance area where the payload is able to just continue on its course that it is going. However, once it leaves this tolerance area, it takes the necessary steps to go ahead and rotate and change its directional vector back into the tolerance zone. With this approach, it allows us to simplify the algorithms and mathematics needed for a successful recovery. Also, we are able to then void out calculating for real-time variables such as wind speed, as our method only reacts to its current position and directional vector.
I'm Madrigal, a sophomore in computer engineering here at Kansas State University. This year, thanks to our sponsors at Altium, we were able to customize and make our own PCBs for not only our ground station, but our payload for the Argonia Cup competition as well. We wanted to have the form factor be as small as possible so that we could still maintain our full functionality of pulling the telemetry off of our payload, but we also wanted to have extra space within our nose cone in our payload to put a servo motor so we can use it to control our active recovery system.
Hi, I'm Brett Funk, a sophomore in mechanical engineering and the vice president of FF Aero. The team plans to test our design at the Rocket Pastures Fun Fly this March. If the payload recovery system fails, we have a backup prepared to use at the actual Argonia Cup competition. This system consists of a simple capsule which will deliver the golf ball to about 1,000 feet above ground level, at which point it will deploy a parachute to safely guide it the rest of the way down.
My name is Ben Murdock. I'm a junior in mechanical engineering here at K-State, and I'm the president of Final Frontier Aerospace. We just want to thank the Cloudbusters for putting on a collegiate competition this year. We're fortunate to have the Rocket Pasture so close to our campus and appreciate the support you provide us, other collegiate teams, and the Tripoli community as a whole. Our team enjoys finding new solutions to this challenge each year. We can't wait to see what the other teams bring and watch some awesome rocket launches. Go Cats, and we'll see you at the Rocket Pasture.